celebrate the launch of Polymaker's new aesthetic product line, Panchroma, we've developed a brand new formula for 3D printing, which at first sight might seem exactly like PLA, but it's not PLA. This is CoPE, a copolyester blend that we fine-tuned to mimic PLA or even outperform it in some printing characteristics, combining ease of use, high-speed printing, the ability to print fine details, steep overhangs, long bridges, and a surface finish to emulate PLA. If we fit a high-flow HTA E3D hot end to an X1E and max out the speed and flow settings to print a speed benchy as fast as this printer can handle, we can compare the results using exactly the same print settings from PLA to CoPE. First of all, shout out to E3D for producing a high-flow hot end that can actually print a 6-minute benchy on a consumer printer. I was hoping this would actually fail. After the PLA print finished, I hit print again, but now using the CoPE filament on the same print file. Side by side, we can see the CoPE has slightly better high-speed printing properties than regular PLA, with the benefits noticed on the bridging, the overhang, and the surface quality. If we take a closer look into CoPE's surface finish with the macro lens on these material scientists, we reveal semi-gloss layers and fine details as good as you'd expect from any PLA filament. And again, these were printed with a regular PLA profile, no tweaks or changes made to the settings. This means that you can run CoPE on existing profiles already saved on your machine with excellent results. To test this, I've printed out this hue forge that I made last month for Formnext featuring Marilyn Monroe, simply adding CoPE colors into the AMS and pressing print. Obviously the TDs are completely different, but Warhol famously played around with colors when creating this artwork. Focusing purely on the printing element, I was very impressed to see the hue forge worked first time on a profile that was designed for Polyterra PLA. This hue forge was printed on a textured PEI sheet with a bit of glue which helped release the print after it was finished. This means you can print these stairs with no brim or glue, but it also means if you have a large surface area in contact with the bed, you could have some difficulty removing the print in one piece. As CoPE is not PLA, it means it doesn't bond well to PLA, so you won't be able to use PLA with CoPE to create hue forge art. But this does mean that you can use it as support material for PLA. To do a quick test, I printed this simple support test without making any changes to the standard support settings. The PLA warped away from the far end but showed promising adhesion signs near the corner here. I ran the test again but changed the Z distance gap to 0 so the CoPE would be printing directly onto the PLA with no air gap, and used CoPE as the interface layer to speed things up. This time the results were much better than my camera work, but I got a good idea of the feasibility. As this was a bit of an ideal test with a flat surface on a flat interface layer, I thought I should investigate a bit further and try and print a material scientist using tree supports in a more real-life example. As this model is designed to be printed with no supports, I flipped him upside down and printed the model on the A1 using the same 0 gap settings with the CoPE as the interface layer. I've just removed all the support from the upside down Polymaker Scientist. I don't recommend printing it this way, but actually it came off really well. I'm at 95%, came off really easily, and the bond feels, right where you'd want it for a support material. Not there's just a little bit of something there, but it's enough that you can flick it away after. Overall, pretty successful as a support material using CoPE with this is Polyterra PLA. So why should you choose CoPE when it's exactly the same as PLA and you're already very happy with PLA? Well, being polyester based means that we can significantly lower the price of our raw materials, as polyesters are one of the most commonly produced plastics worldwide. So you can enjoy PLA results with better than PLA prices. Aside from the printing, don't expect much from CoPE in terms of mechanical properties, as the layer adhesion does leave something to be desired. However, for the price and printability, CoPE's performance is the best on the market. For a quick prototype, a decoration with fine details, or even a support filament for PLA, CoPE is definitely a spool you want in your toolkit.